Sixth grade math lesson 3.8 is talking about ordered pair relationships. And this is where we introduce the idea of quadrants. And before we get into talking about the quadrants, I want to do a quick lesson on Roman numerals because they use Roman numerals instead of Arabic numerals like we use to name the quadrants. So I'll do a quick lesson, or for some of you it's a quick review. One I represents the number 1. 2 I's represents the number 2. Easy so far, right? 3 I's represents the number 3, because there's 3 I's there. I skipped 4, we'll come back to it. The letter V represents 5. So what happens is we're always trying to avoid having to do more than 3 I's. So if 5 represents, as V represents 5, then 1 in front of V, or 1 before 5, is 4. 1 before 5. And these are the ones we need to know for our quadrants in case you're curious. If you probably are kind of guessing and thinking ahead, 6 would be 1 after 5. 1 after 5 is 6, right? 7 is 2 after 5. 2 after 5. 8 is 3 after 5. And then you go on to 10, which is X. 1 before 10 is 9, etc. So you don't need to worry about those. The ones you need to worry about, not right now anyway, the ones you need to worry about right now, 1, 2, 3, and 4. So those are the numerals, the numbers that are used to label the quadrants. And so now let's talk about quadrants. So a quick review on our coordinate plane. We have 2 number lines that overlap. One is horizontal. We call that the x-axis. They overlap at 0 for both of them. So this is 0 for the x-axis with my positives, 1, 2, 3, and so on this way, and my negatives, -1, -2, -3, and so on, going that way. The overlapping y-axis starts at 0 as well. That is our origin, where both of them are at 0, the x and y-axis, where positives are 1, 2, 3, and on, upward, and negatives are -1, -2, -3, and downward for the negatives. So 0 is where they overlap. In the positive on the x turn and go positive on the y, this whole section, because there's 4 pieces, right, to the coordinate plane. Quad is 4, so quadrants are referring to the 4 pieces. The positive side is quadrant 1. So I'm going to put as our ordered pair positive, and we're going to go ahead and put quadrant 1, Roman numeral 1. In our positive sorry, let me say that I said that the wrong way. In our negative on the x turn and go positive on the y, negative on the x turn and go positive on the y, that is quadrant 2. So what you're going to find is the quadrants start at positive, and then they go counterclockwise around. Start at positive, counterclockwise around 1, 2, 3, 4. On our negative on the x turn and go negative on the y, negative, that is quadrant 3. And finally, our positive on the x but negative on the y section, positive on the x but negative on the y section, that is quadrant 4. So I used to have my students in class do this dance, and I would have them stand up and they would imagine the coordinate plane in front of them. 1 would be up at reach their arm up to the top right. 2 would be reach their arm up to the top left. 3 would be reach your arm down to the bottom left, and 4 would be reach your arm down to the bottom right. And I would just start reading off quadrants, and they would just tap around to do it. So if you want to get that stuck in your head, do something like that to get where those quadrants are located in your head. But you can just always remember, if quadrant 1 is the positive, positive, positive on the x, positive on the y, and then it counts counterclockwise from there. 1, 2, 3, 4. There you go. So our unlock the problem from page 131 is telling us that the point -3, 4, the ordered pair -3, 4, remember that's on the x number line, turn, and then go that on the y number line, represents the location of a bookstore on a map of a shopping mall. Identify the quadrant where the point is located. Let's underline our question and circle our given information. And they even help us, what is the x coordinate, what is the y coordinate. They help us break this down because they know our brains are still adjusting to this. I go this much on the x, -3 on the x, then I turn, and I go this many, 4 on the y. So the coordinate for the x coordinate is -3, and the y coordinate point is 4 right there. So I'm going to start at my origin and go to -3 on the x, there, turn, then go +4 on the y, there, and mark that location. Their question is, what quadrant is that in? Now, normally, you will not see the quadrants listed here, 1, 2, 3, and 4. Usually, when you see a coordinate plane, they don't say that, and you're not usually asked that, but it's important to know because you may need to refer to it at some point. So, this is positive and positive, so that's the quadrant 1, and then you go counterclockwise from there, 1, 2, 3, 4, counterclockwise, in case you didn't know. Counter is meaning against, so clockwise goes this way, the opposite or against clockwise goes that way. So counterclockwise, when you hear people say it, means opposite of what the clock does. So 1, 2, 3, 4. And so my point is sitting here in quadrant 2, so my answer is that quadrant 2 is where it's at. And then just keep in mind, this is something that will make things easier later. My quadrant 1s are always positive positives. My quadrant 2s are negative on the x, positive on the y, negative on the x, positive on the y. My quadrant 3s are negative on the x, negative on the y. And my quadrant 4s are always my positives on the x and negatives on the y. This section also talks about lines of symmetry, and I'll write that out, lines of symmetry. Symmetrical means like it matches on both sides, so lines of symmetry has to do with things matching. So think about if I had a paper that was shaped like a triangle, and my goal, if I'm using a line of symmetry, is to be able to fold that so that the pieces match both sides, that they will touch both sides. So like if I folded it here, and I folded this part, this bottom part up to match this part, it wouldn't match, right? These pieces over here would be sticking out. So that wouldn't be a line of symmetry. A line of symmetry, though, that would work would be a cut that comes straight down the center here, because if I fold on this line, this section, over on top of this section, then they will match. They're mirror images of each other, and that is a line of symmetry where if you fold it on that line, it will be a match. So this is a line of symmetry. I'll put a happy face, yay. This is not a line of symmetry because if I fold along this line, this is not going to match that. There will be a bunch of overlap. It will be messy. So I'll put a sad face for not line of symmetry. Oh, all right. How about on this rectangle? If I fold it right along the center and I fold those over, yes, line of symmetry. If I go across on the rectangle right at the middle and I fold it there, assuming I put that line right in the middle, pretend it's right in the middle, yes, line of symmetry. Something that would not be might be like this, where I have a little piece here and a bigger piece there. That's not a folded line of symmetry there, because when I fold it along this line, they're not going to match. So no, not that. And same if I go along this way. that's not going to be a line of symmetry because that's tiny, tiny, and that's big, big. So that would not be a line of symmetry either. So that's just something to keep in mind on line of symmetry. It's just the folding point that you could make where your pieces would match perfectly. So keeping that in mind, we'll look at the next piece of the next activity. So in this activity, they want us to identify the lines of symmetry in this rectangle. So here we have this rectangle here, and they want us to identify possible lines of symmetry. Maybe you recognize them right away, but maybe not. And so let's walk through the steps that they have us do to help your brain recognize them or to verify that you did recognize them. So the which axis is the horizontal line of symmetry? The X. It's going straight through, right? And which is the vertical line of symmetry? Here, going straight through center. You notice that these are going straight through center. X goes straight through the center. So if I fold this section and this section, then they will meet. Y is going straight through the middle of this section and this section. So if they folded, they'd meet perfectly. So those are the two lines of symmetry in this. So look at points A and B. What do you notice about the X coordinates? What do you notice about the Y coordinates? So let's look at the X coordinates. Here it crosses over our X number line, 5 and 5. Those X coordinates are 5. They're the same. And here at C and D, they are also, they're -5, -5. Remember, by absolute values, this is 5 away from 0, and this is 5 away from 0. So they are equal distance from 0. If we look at the Y coordinates for D and A, this is 4 away from 0. And if we look at the Y coordinates on B and C, that's a -4. Absolute value 4 steps away from 0. So this is 4 away from 0. That is 4 away from 0. So I put down that we just noticed that they are equal distance from 0. They're not equal numbers. -4 and 4 are not equal numbers, but their absolute values are equal distance from 0. So that's what we were looking at. Point B is a reflection of point A across which axis? So here I have point A and I have point B. Where would I have to fold it? Along the x-axis or along the y-axis to get them to touch? I'd fold it along the x-axis, because if I fold it on the x-axis, they will touch. Let's look at points A and D. What do you notice about the x coordinates, A and D? This is 5 and this is -5, absolute value of 5, absolute value of 5. So we notice that they are equal distance from 0. And what do we notice about the y coordinates? They're both the same. They are +4 on the y-axis. And then they ask us, point D is reflection of point A across which axis? Point A is a reflection of point B across which axis? Well, where would I have to fold, along the y-axis or along the x-axis, in order for D to touch A? I would have to fold it here, right? So along the y-axis is the answer, because they are both equal distance away from the y-axis. So my answer is the y-axis, because they are equal distance from y, and if I fold it there, they will touch. Which point is a reflection of point B across the x-axis and then the y-axis? So think of a piece of paper. We're going to fold it once, and then we're going to fold it again. And so our brains are going to have to translate that. And if you need to, get a piece of paper out and mark it, and then we'll fold it. We have point B right here. If I fold it across the x-axis, that's here, there's my fold line. I'm going to fold it upwards. Which one is it touching? It touches A, so it folded upward. Then I fold it across the y-axis. So here it is now here, and I fold it over across this fold line. Where am I touching? Hopefully your brain notices D, or if it didn't catch that, get a piece of paper, put a coordinate plane with points that are equal distance and label them A, B, C, D, and then go ahead and fold at the X so you can see that B touches A, and then fold that again on the Y, so you could see that that A and B will now touch D. And finally, so we found that it would touch D, and they said, well, compare the coordinates of B with the coordinates of D. So here's B's coordinates, positive 5, negative 4, and here's D's coordinates, negative 5, positive 4. So those are those opposites, right? That would be the opposite all the way diagonally across is when you see that happening. So they're just trying to get you real familiar with the manipulations of where things fall on the coordinate plane. So big things to keep in mind in this lesson is the quadrants: 1, top right, 2, top left, 3, bottom left, and 4, bottom right. The start at the positive on the X, positive on the Y for quadrant 1, and then move counterclockwise from there. It may be helpful for this lesson to have that in your notes out and ready so you could see where those are at. That's one of the pieces that this lesson wants you to know, is just name the quadrants. And it also may start asking you a little bit about lines of symmetry. Where would you fold it so that they match? So I think you're okay to get going on this. Good job today. And let me know if you need any help.